Welcome back to the class of Math 1450, Math and the Modern World. This time we are moving into a new chapter. It's chapter 5. It's algebra. Math, it's all about numbers. So this time we are talking about notations on the numbers and operations on notations and numbers. Okay, so it's called algebra. Again, we do have the textbook. The textbook, it is. You can click on the top of the lecture notes. There is a link directly to the textbook. Okay, it's openstacks.org. It is just free. It is just free. And for now, we are in chapter 5. We are working on algebra. Okay. And the learning objective for this chapter, for this particular first section, section 5.1, algebraic explorations. First of all, make sure you do understand what an algebraic expression is, and you are going to work on and simplify, and you are going to evaluate and operate on algebraic expressions. So they are listed on the lecture notes too. There are 4 tasks. Pretty much that's all about evaluation and operations. And for both evaluations and operations, I want to say basically they do involve 4 basic operations: addition, subtraction, multiplication, and division. Okay, so let's take a quick look. The first example, which is directly from the book, example 5.6, it is about to evaluate an algebraic expression. So you look at this is the algebraic expression I'm talking about, and you see there are numbers and the notations. X is a notation. And by the way, it's worth to mention in math. Okay, not only numbers, we do use notations, and especially you see X a lot. Okay, X, Y, Z, and A, B, C, D, all the letters. We do use all the letters to denote a number. So this time we are having an expression 3x plus 5, and we want to evaluate this expression when x equals 2. It's a very straightforward thing. You simply replace each occurrence of x with 2, and you do the calculation. So this is the number I calculated, and you want to help me if I get the number correctly. Okay. And second example, we are having an expression a little more complicated. Not only addition, subtraction, multiplication, and no division in this case, but we do have the exponential operation. We do have exponent 2, and want to evaluate the new expression when x equals 2. Pretty much you do the same thing. You simply replace each occurrence of x with number 2, and clearly there are 2 occurrences of x, so you plug in 2 times for x and do the actual evaluation. And this is the number I calculated. I think it should be all right. So that's all about evaluation expression. An algebraic expression may have numbers and notations. And in our case, we have multiple numbers, but just one single notation. Later on, we may have an algebraic expression with multiple notations. But for the moment, it is just a single notation. And also it's worth to mention, the first expression you see, the notation x. Okay, there's no power for notation x. And x is not anywhere in the denominator. So this kind of expression, it is called a linear expression. The second one, there's a power term. There's an exponential term. And a term with a power with an exponent, x squared. But still, x not anywhere inside the square root or in the denominator. So this is a quadratic expression. Quadratic expression, linear expression. And then in terms of operations of algebraic expressions, basically there are, well, in general, you want to say there are four operations: addition, subtraction, multiplication, and division. But also, I just want to remind you, in math, you will have to understand subtraction. It is just like addition, adding by the opposite. Okay, adding by the opposite. So subtraction, it is just a special kind of addition. And a similar division, it is a kind of multiplication. When you multiply by the reciprocal number, it's the same as divided by the number, division by the number. So addition, I'm saying addition and the subtraction really should be treated the same, and the multiplication and the division should be treated the same. So mostly from now on, you see, most of the time when I talk about operations, I just try to emphasize addition and multiplication. Okay. And also a little more things to clarify. When you look at the expression, it may have multiple numbers and multiple notations, and there are terms. Okay, so in a simple way, a term, it could be a single number, we call that a constant, or it could be in the fashion of a constant multiply a notation, or a constant multiplied by a notation to the power. Okay, so for example, we are having, these are considered as terms. A single number 7, it is a term. Well, notation this time we have notation y, right? And then we have a constant multiplied by a variable raising to the power. That is a term. And this is a term 2, and this is a b raised to the power of 5. B raising to the power of 5. Okay, I can fix this part quickly. This is a notation. So actually, I did not do it correctly. I mean, this it is. Make sure you understand this part. I'm talking about the b raising to the power of 5. B raising to the power of 5. It is a term. It is a term. That's what I'm saying here. Okay, that's a term. Okay. And then the number in front of the notation, it is called as a coefficient. So in this case, this number 5, it is a coefficient for x squared. Number 9, it is a coefficient for a. Okay. And also in a rare case, you see this b to the 5, the term right just fixed it. Looks like there's no number before that b, right? But you really want to say there's a coefficient of 1. 1 times b to the 5. Every single term has a coefficient, okay? So these are the basics for the algebraic expressions. And also the other thing I want to mention, it is the so-called like terms. Like terms are the terms with the some common things, with common notations, and raising to the same power, And we can work through the next example, so you can better understand what do we mean by like terms. Okay, so this is the example. It is to add to algebraic expressions. And now you look at the parentheses. There are 2 pairs of parentheses. Basically, we are going to add those 2 expressions. And in each pair of parentheses, there is x squared. And there's another term with x squared. These are the terms, what we call as like terms. So in order to add those 2 expressions, first thing I did is just remove the parentheses. And then I try to combine like terms, which basically just means put the like terms together. Like x squared, 3x squared, they are like terms, adding them together. And the term with x, 4x minus x, they are the like terms, I have them together. And the numbers together, -9 plus 12 together. And also, as I just mentioned, indeed in my classes, I always try to emphasize, do consider addition and subtraction the same. So I put add, look at this last line of writing here. I have the plus sign first, and then use the pair of parentheses, -9 plus 12. I just want to say, well, this is really how it works. All the terms are connected by the plus sign, but the term itself could be negative or positive. So accordingly, we may have plus sign or minus sign, okay? And then finally, we got everything simplified. This is the final result. This is the final result. This is the final result. Adding two expressions. Basically, it really means, I want to say really, it really means combining like terms. Adding two algebraic expressions simply means to combine like terms. And subtraction, the next example, it is for subtraction. So as I just mentioned, really subtracting, it is addition, right? Subtraction, it is addition. So the first thing, when I want to subtract those two terms, I try to remove the parentheses, especially for the second pair of parentheses. You may want to see the minus sign, it is in front of this pair of parentheses, which really means when you remove the parentheses, you want to change the sign for all the terms inside. So accordingly, 3x squared turns to be negative 3x squared. It's negative x, you have to change the sign. You have to flip the sign. It turns to be plus x, and then plus 12 turns to be negative 12. The remaining part, well, it's just like addition, right? It's just like addition. It's just like addition, combining like terms. And this is the final result we are getting. This is the final result we are getting. Addition and subtraction. And I'm going to pause a little bit. You take a look. If you have any questions, it's about algebraic expressions, adding and subtract algebraic expressions, combining like terms. And now we'll give a try. Can you tell yourself what like terms are? What like terms are? These are look-like terms, okay? Especially in math, in order to have like terms, make sure you are seeing the same notation and the same notation relating to the same power. These are the like terms. Algebraic expressions. And also we do have multiplication and division. So a little more examples on multiplication. The first one, we want to multiply this out. Even though this 5, it is in the end, in some way, I would say if you feel more comfortable, you could move to the 5 to the front. Okay. Either way, you will have to distribute this 5 to each and every single term inside the parentheses. So this is the result I am getting. And the next one, starting from -3, multiplied by the second pair of parentheses. So you do the same. You will have to distribute this -3 to each and every single term inside this second pair of parentheses. And this is the result I'm having. And by the way, I just saw a typo here. This should be 3y, 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 okay. And then the next expression, it might be a little harder for you to see here, but anyway, I just want to make sure this is actually number 5 squared. 5, yeah, I think I can make it a little better. It is 5 squared, okay, it is 5 squared. 5 squared times 7 plus 3 times x. So according to the order of operations, whenever we have parentheses, we can carry out the operations inside the parentheses first. And then comes with the exponential operations, exponents. So 5 squared turns to 25. And then we have all about multiplication. They are in the same level, so we proceed from left to right. This is in the end, the answer I got. Number 4, number 4 and 5, I really want to say you want to look at both together. The only thing I want to mention here is parentheses. Parentheses are important, okay? They do make differences. They do make a difference, okay? Like number 4, there's no parentheses because of the order of operations, x times 5. It is just like 5 times x. So there's really not a lot of simplification we can handle here. And maybe putting it this way, by the way, it's worth to mention sometimes. Well, it's not always the case. And for those simple expressions, if we put some easy and simple things first, and then notations, or especially I'm saying number first, then the terms with notations, okay. So simply we are writing this as 4 plus 5x. We really did not do a lot. Pretty much it is very much simplified, okay, the problem itself. As I'm saying, the other thing I really want to mention here is the second expression, okay, with parentheses. And we understand with parentheses, we will have to consider the operations inside the parentheses. But anyway, in this case, 4 plus x, there's not a lot we can do. But together, okay, with parentheses, it's simply say together multiply by 5. So according to the distributivity of multiplication, we multiply this 5 to each and every single term inside. So it turns to be 20 plus 5x. So again, I'm saying you want to look at number 4 and number 5 together. Okay, you see the difference. The difference, it is parentheses. The pair of parentheses, okay. It does make a difference. Okay, it does make a difference. And let's take a look. Yeah, we do have an example of multiplying algebraic expressions. I want to say this is all about the FOIL rule. When an expression, there are 2 terms with for an expression, we call this as binomial. There are 2 terms inside the first pair of parentheses, and 2 terms inside the second pair of parentheses. So each, it is binomial. When we multiply binomials, we can use the FOIL rule. F stands for the first term, O is for the out term, I it is for the inner term, L it is for the last term, L it is for the last term. So accordingly, when we consider multiplication, I get the product of 2 first terms, and this is the product of 2 inner terms, right? This is the product of 2 out terms. And this is the product of 2 inner terms. And finally, the product of 2 last terms. Look at this number 9, 4x minus 9. I hope you see it clearly. I really considered this as 4x plus negative 9. Okay, so in general, we say, well, an expression, it is connected by plus sign. And minus 9 should be considered as plus negative 9. And also, when you write this negative 9, do use a pair of parentheses. See, negative 9 parentheses, negative 9 parentheses. And then you proceed. And this is the simplified answer. Multiplying 2 algebraic expressions, especially the FOIL rule for the multiplication of binomials. One more example for this section, division between algebraic expressions. Because of the nature of this class, we are not going too deep into all those operations, especially for division. We are just going to consider, well, a polynomial. Well, this kind of expression, it is a polynomial divided by a single term. So make sure you do understand, well, the division by a single term basically means, which means each and every single term from the numerator divided by the same denominator. So this is in a fractional form, division. It is a fraction, right? A fraction, it is for division. Each and every single term divided by the same denominator. And then finally, I got it simplified. And not to summarize this first section of chapter 5, it is about algebraic expressions. And make sure you know how to evaluate the value of an algebraic expression. You know how to add to algebraic expressions, subtract algebraic expressions, multiply, and divide algebraic expressions. Thank you for watching.